Some of terms are not that familiar to students, so I would like to give some idea about what is the basis functions, or what is the transform. You know that transform is actual functional dot product. What's the meaning of a functional dot product? So this is called a functional dot product. So to know that the transform, you need to know that what's the meaning of that. I would like to explain about that. Okay, here in high school age we talk about the vector and dot product. Okay, this one is x-axis, this one is y-axis. Then here is a coordinate. The coordinate is x component is 4, y component is 3. Then this point referred to 4.3. X component is 4, y component is 3. We can express in that way. And also the same thing can be explained by the vector. This red dot vector has these directions. Magnitude, you know that by use of Pythagorean, 4 and 3, this one should be 5. Length is 5, angle is theta 1. So we know that how to express that one. Okay, here vector 1 has coordinate 4.3, and the basis means this one. Okay, this vector is called basis in the vector space 1, 0. This one is x basis function, basis vector, and the y basis vector is this one, 0, 1. X component is 0, y component is 1. This is called y. So x hat and y, these two vectors is called the basis vector. You know that it has the same meaning of this basis. Okay, so at here I hope that you may know that what's the meaning of the basis. Then if we know that the basis, we can decompose this vector into 4 times x hat. So x direction, it has 4 components, and y axis is 3. So we can express a 4 times x hat vector plus 3 times y hat vector. Okay. The another one is the dot product. It's a self dot product defined by this one. Dot product can be happen v1 dot product, v1 vector are given 4 times 4, x component multiplied by x component, y component producted by y component. By summing that, that's the dot product definitions. So in this case, this is 16 plus 9. So that's shown here. So by taking the self dot product, this one will give v1 magnitude square. Okay. So by taking square root of them, we can calculate the magnitude of vector. That's the 5, this length. Okay. Another point of view, the v1 vectors x component can be found by this dot product. You know what? X hat magnitude obviously 1. Okay, this is 1. And the x hat dot product, y hat dot product will give 0. You know that 0 times 1 is 0, 1 times 0 is 0. So if dot product goes to 0, we call that is orthogonal. Orthogonal. You know that x hat and y hat are right angle. This is a right angle. Other name is independent. So it doesn't depend each other. Orthogonal or independent is the same meaning. So usually we are taking basis with this property, orthogonal and independent. Okay, that's the basis. And to figure out the x component of the v1, we can make a dot product of this one. Then 1 times 4, 0 times 3, that's obviously 4. This is defined by the cosine relationship. 5 times cosine theta 1 becomes the 4. To figure out the y component, we can make a dot product with a y basis. Okay, v1 times y hat. This basis is producted. You know what? v1 dot product y hat can be understood in this way. 4 times x hat plus 3 times y hat. Dot product y hat. Y hat dot product x hat goes to the 0. This goes to the 0. This product will give 3. Other way, you know that this one is a 4 0. 4 3, sorry. This one is a 0 1. So by taking producting 0 times 4 goes to the 0. 3 times 1 equals to 3. At here, you need to focus on the dot product. What is the dot product? What's the meaning of that? So firstly, self dot product gives a magnitude square. By taking square, it gives the magnitude of that one. So here we talk about the basis functions, basis vectors of x hat and y hat. So x hat and y hat gives this row vector 1 0 and 0 1. And if we using this basis vector here and v1 is multiplied here, that will give x and y component given like that. So this one is v1, this one is basis vector. So by taking product, dot product, we can have its component evaluated. And v1 can be expressed by this way: 4 times x hat, 3 times y hat, or we can express that one in the coordinate system like that. v2 are given like that. So v2 has a x component is 3, y component is 4. That's the v2. Okay, see here. So v2 is magnitude is 5, the same as this one. The angle is theta 2. Okay, and I would like to explain the dot product between v1 and v2. That's shown here. We know that the magnitude of v1 and v2, both of them, their magnitude is 5. v1 magnitude is 5 and v2 is the same. The dot product between v1 and v2 is just a projection, as we have done at here. Okay. To interpret the dot product, you can refer to this part. So v1 dot product as said, we can interpret v1 projected to x hat vector. Then this can be explained by this one: v1 magnitude times x hat magnitude. And we know that this one is x hat and this one is v1. And the angle is theta 1, cosine theta 1. So if you referring this one, x hat magnitude is 1 and v1 is 5. 5 cosine theta 1, that's this one. Okay, this is the dot product between v1 and x hat. Okay, what about this one? In this case, we take a dot product between y hat versus x. This is y hat. Okay, versus this one. This dot product is this one, v1 y hat. Can be understood in this way: v1 magnitude times y hat magnitude. Obviously, y hat magnitude is unit. And cosine. Now this angle should be taken. But this angle can be expressed by theta 1. That is a pi over 2. That's the 90 degree minus theta 1. Okay. This one equals to theta 1. And this is 1. So this is 5. So we can understand the dot product is given like this way. Its magnitude is producted and taking cosine between the angles. Okay. Now we would like to take in dot product v1 and v2. That will give 3 times 4, 4 times 3. That is, you know that, that is obviously 24. You know that. v1 dot product v2 can be calculated by x component. You know that xy component goes to the 0. It means that okay, v1 dot product v2 are given like this way: 4 times x hat plus 3 times y hat dot product, and 3 times x hat plus 4 times y hat. And we know that this orthogonal property. By multiplying in this way, it gives 12. And the producting this one will go to the 0, because y hat dot product x hat should be 0. Similarly, we can try that one like this way. 4y hat times 4x hat should be 0. And by taking dot product between 3y hat, 4y hat, y hat to the y hat should be 1. That's the 12. So we have dot product is 24. This is just calculations. What's the meaning of that one? The meaning is this one. V1 magnitude and V2 both of them is 5 and 5. So this one result is 24, but the output looks like this one. 24 should be equals to 5 times 5. That's the 25 times cosine phi. What is the cosine phi? This is the phi, the angle difference. So the angle between these two vectors is cosine phi, the angle is phi. So cosine phi can be given like this one. Sometimes this one is called correlation coefficient. So you know that the cosine phi can taking maximum is 1, minimum is -1. So the special case cosine pi of 2, okay, pi over 2 are 0. This is right angle. So in case of right angle, I said that the orthogonal or independent. If two vector dot product goes to 0, those vectors are independent or orthogonal. Okay. So this dot product is very useful in the vector space. The same thing can be applied in the signal space. And here we have two input sequence, x1 and x2. It has 1, -2, -3, 1. That's the x1 sequence. x2 sequence is -1, -3, 1, 1. So we would like to find out dot product of this one. Dot product will give the similarity between two sequence. So dot product is quite not that difficult. You know that if I taking x1 c dot x2, taking dot product will give 1 times -1 will give -1, and -2 -3 will give 6, and -3 1 will give -3, and 1 and 1 gives 1. Then the dot product will give -4 plus 2 3. Okay, so this is the dot product between these two signals. But we would like to find out the cosine value of the angle. So we need to find out the cosine phi. So to find out that one, we need to refer to x1 dot x2 divided by x1 magnitude, x2 magnitude. So magnitude of x1 and x2 can be found from the dot product of the x1 self dot product, x2, x1. So this one will give 1 plus 4 plus 9 plus 1. You can take just the scale of each component. Then it will give 15. So magnitude of this one will give square root of them, 15. Okay, we got that one. And what about x2? We'll give 1 plus 9 plus 1 plus 1. Okay, that's the self correlation, self dot product. Okay, then it will give 12. Okay, so x2 magnitude is the square root 12. Then we can figure out the result. Looks like this one. dot product will give 3, but it will give 15 times 12. So let's figure out 3 divided by 15 divided by 12. This one. So this value is about 0.02236. Okay, I would like to mention that what's the meaning of this one. We call that is a correlation coefficient. Okay, so how similar between these two signals, or the other one is x1 sequence projected to the x2. So another point of view, you can think about x2 contains x1 component this much. So it means that there is some similarity. The similarity is quantified, this number. So you can think about x2 has x1 component of this much. Okay. Now I would like to move on to the functional space. In the functional space, I assume that these x0t, x1t, x2t are defined on -1 and 1, in between -1 and 1. So x0t is constant, it's 1. x1t is t, x2t is t squared. I would like to find out the magnitude of each functions. So to find out the function, we need to take a dot product between functions. So it means x0 dot product x0. This one, okay, defined by integration the whole range -1 to 1 and x0t dt. So this one is a dot product between the x0. So I can calculate that one. You know that x0t is 1, so that is obviously 2. It means magnitude of x0t r equals to square root 2. Okay. Similarly, what about x1 c dot x1t? So it's the same. So x1t is t square c dot dt. Okay. x1 dot product between x1 and x1 self product is defined like that one. Then it will give 1/3 t cube over 3, and the integration should be taken -1 to the 1. Then it will give 2/3. Therefore, magnitude of x1t equals to 2/3. Okay, this is it. The last one is x2. Okay, x2. Okay, x2t c dot x2t. Okay, are defined by integration -1 to 1, and by self-producting it becomes the t to the 5. Okay. Okay. 4. Sorry. T to the 4. So t squared times t squared are given as t to the 4, and it will give t to the 5/5. Okay. I take this one. It's t to the 5/5, and this integration -1 to up to 1. Then it will give 2/5. Therefore, x2t magnitude are given. Sorry, 2/5. So we got the its magnitude of this one, we find out the magnitude of x0, x1, and x2 by use of dot product definitions. Functional dot product looks like this one, x1 times x2 times, and take integration over the domain. Domain is defined like that. So the next one, we would like to find out its angles of the functions. So how much similar? The first one, I would like to calculate the angle between x0 and x1. What will be the angle? To find out the angle, I have to take in dot product of x0t, x1t. Okay, that is integration minus 1 to the 1. X0 is 1, xt is t. So this one is x0t, x1t are given as a t. This one obviously is 0 because this one is odd function. It means that x1 and x2 is orthogonal or independent, and we know that the cosine phi, the angle are given like the x0, see that, x1 over and over, like okay, this one is x0 magnitude, x1 magnitude. Anyway, the numerator is 0, denominator is square root 2 and square root 2 over 3, whatever the denominator, numerator is 0, that's why it's 0. It means x1 and x0 and x1 are orthogonal or independent. Okay, what about the next one? Next one is x1 to x2 angle. Okay, let's specify this color. So I would like to calculate the angle between x1 and x2. To find out that one, I can take in dot product between two functions. Okay, we can take in integration the whole range, and x1t is t, x2t is t to the square. Okay, this is t and t to the square, and c dot dt. Then it will give obviously this is also okay, this one is 3, 4, this is also 0 because this is other functions. Similar way, this is also orthogonal. Okay, it's 0, the same reason. The last one, I would like to calculate angle between x2 and x0. So I would like to calculate x2t, so that x0t, that is defined minus 1. Okay, 2, 1, and x2t is t to the square. See that x0t is 1. So 1, I can remove that one. Okay, we have to take in integration of t to the square. Then it will give t cubed over 3, and starting minus 1 to the 1. Then it will give if you enter the 1, that becomes 1, minus 1 will be minus 1. By taking subtraction between them, will give 2 over 3. Okay, this is the product. Then we know that the cosine phi are defined by x2 dot product x0 divided by magnitude of this one. So x2 magnitude, x0 magnitude. Then the numerator becomes the 2 over 3. But denominator is product between the 2 over square root 2 over 4 and the square root 2. So it will give 2 over 5 times square root 2. So square root 2 will give 2, that will cancel each other, and square root of 5 will come over like that, 5 over 3. So I can calculate 5 over 3 are given 0.74. So this one is 0.745. So we have the cosine value of the angle. Okay, this is the functional dot product. We defined what is the dot product. Okay, starting from the vector space, we defined dot product of vector, and then we try to calculate the dot product between two different discrete sequences, x1 and x2, and interpret the meaning of that. We can using the same definition of dot product of the vector space. And the last one, we refer to the functional space. Function defined in between -1 and 1, and x0t, x1t, x2t are defined like that one. Only this one is defined on this period, except that period all the function is 0. So only function can take integration over only this range. Okay, so in the cases we can calculate the magnitude of each functions by use of the dot product definitions. Functional dot product is defined like this, the integration of that, and we can calculate the angles between functions by taking the dot product, the cross functions x0, x1, and x1, x2, and x2, x0. We can figure out the x0, x1 are orthogonal or independent. x1, x2 also orthogonal. But x0, x2 are not orthogonal. It has some relationship. It means there is some entangled between x0 and x2. That's the given like this way.